Ever wondered how the tiniest particles in the universe behave in ways that defy common sense? Welcome to the fascinating realm of quantum physics, the study of matter and energy at its most fundamental level. A world where the rules and regulations differ considerably from what we're used to in our everyday lives. Now let's take a step back. In classical physics, we deal with the macroscopic world. It's the physics of apples falling from trees and planets orbiting stars. Things that we can see, touch, and feel. However, when we delve into the microscopic realm of atoms and subatomic particles, we enter the domain of quantum physics. Here, particles can exist in multiple places at once, pop in and out of existence, and even affect each other instantaneously over vast distances. These phenomena may appear strange and counterintuitive because they're beyond our everyday experience. Quantum physics may seem bizarre, but it's the key to understanding the fabric of reality itself. Imagine being in two places at the same time. Sounds impossible, right? Not in the quantum world. Here, we encounter a fascinating phenomenon known as quantum superposition. This mind-bending concept posits that a particle can exist in multiple states simultaneously until it is observed or measured. Let's delve a little deeper. Picture a box with a cat inside. According to the famous Schrödinger's cat thought experiment, if there's a mechanism that could randomly kill the cat, then before we open the box, the cat is in a superposition. It's both alive and dead at the same time. Bizarre, isn't it? But the moment we open the box and observe, the cat chooses its fate, and the superposition collapses. It's either dead or alive, not both. This is the crux of quantum superposition. In the quantum world, until you check, the cat is both alive and dead. What if an action here could instantly affect something elsewhere, no matter the distance? Welcome to quantum entanglement. Consider this. Pairs or groups of particles become so deeply interconnected that they practically share the same existence. This is the essence of quantum entanglement. The state of one particle is intrinsically tied to the state of the other, no matter how far apart they might be. Change the state of one, and the other changes instantaneously. Now you might be thinking, but how is that even possible? Well, the truth is, even the brightest minds in science have struggled with this concept. Albert Einstein, one of the greatest physicists of all time, once famously referred to quantum entanglement as spooky action at a distance. Despite its eerie undertones, this phenomenon is a fundamental part of quantum mechanics. So let's remember to embrace the strange and the inexplicable. Quantum entanglement. It's not magic, it's physics. Can you know both the speed and position of a particle at the same time? Quantum physics says no. Let's delve into Heisenberg's uncertainty principle. This principle, one of the cornerstones of quantum physics, asserts that it's impossible to simultaneously measure the exact position and momentum of a particle with absolute precision. You might be thinking, well, maybe our tools just aren't precise enough. Interestingly, this is not the case. The uncertainty principle is not a limitation of our measurement tools or techniques. It's a fundamental property of the quantum world itself. Imagine trying to pinpoint a buzzing bee in a dark room. The more you focus on the bee's speed, the buzz and hum, the less you know about its exact location. And as soon as you try to locate the bee, its speed becomes uncertain. This is the essence of Heisenberg's uncertainty principle. The uncertainty principle reminds us that the quantum world is a game of probabilities, not certainties. You might think quantum physics is all theoretical, but it's actually in your everyday life. Indeed, the strange and fascinating world of quantum physics isn't just for scientists in lab coats, it's at the heart of many technologies we use daily. Take semiconductors, for instance, the essential components in our phones and computers. They wouldn't function without quantum mechanics. Lasers, which are used in everything from barcode scanners to medical equipment, are another real-world application of quantum physics. Ever used a GPS to navigate? Well, that's quantum physics in action too. The accuracy of GPS systems relies on understanding how gravity affects time, a concept straight from the playbook of quantum mechanics. Looking forward, the applications of quantum physics are set to become even more astounding. Quantum computing promises to revolutionize data processing, while quantum teleportation could redefine our understanding of distance. From smartphones to future supercomputers, quantum physics is shaping our world. Quantum physics has been put to the test in countless experiments. Let's explore some of the most famous ones. Firstly, there's the double-slit experiment, a fundamental demonstration of quantum mechanics. It shows that light and other forms of electromagnetic radiation can exhibit both wave-like and particle-like properties. When photons are fired through two slits, they create an interference pattern on a screen behind, as if they're waves interacting with each other. Then, there's the Bell's inequalities tests, which deal with spooky action at a distance, or as the scientists call it, quantum entanglement. These tests have repeatedly shown that entangled particles can influence each other instantaneously, no matter how far apart they are. Lastly, the quantum eraser experiment, a mind-bending experiment that seems to imply that choices made in the present can influence the past. These experiments prove that the quantum world, while strange, is very real. Quantum physics has come a long way, but we're just scratching the surface. As we journey forward, intriguing fields like quantum gravity and quantum biology beckon us, promising to extend the reach of quantum theory even further. These are realms where gravity's grip meets the quantum quirks, where life's complexities intertwine with quantum phenomena. The quest to understand the universe on this fundamental level is more exciting than ever. As we delve deeper into the quantum world, who knows what we'll discover next? Quantum physics challenges our understanding of the universe. Indeed it does. It's a realm where particles can be in two places at once, where entanglement links particles across vast distances, and where uncertainty reigns supreme. It's a science that's given us everything from quantum computers to quantum teleportation experiments. It's a glimpse into the future, where the impossible becomes the norm. In the quantum realm, the impossible becomes possible, and the universe reveals its true, strange beauty.